I'm David MacMahon, and we are here in the Digital Lab in the New Campbell Hall. Welcome. This is probably the most current thing we do here. This is some FPGA boards that we have and some GPUs that we use. This is a GTX 780 Ti. This one's a little bit older than the ones we use currently. Then we have Titan X's that we use, but it's sort of the same concept. These go in computers and punch the numbers that come out of the FPGAs. FPGA is a field programmable gate array. It's a chip that has a lot of configurable logic blocks in it. It can be set up however you want. It's sort of like a bunch of building blocks, and you write this sort of program for it. You can make a new design and program the same chip with a completely different design to do a completely different function. So it's very flexible. They're specialized that do things in parallel, and so you can process a lot of information through them when you have a very sort of specific task that you want to do. This is built by Casper, which is a collaboration for astronomical signal processing and engineering research. The signal comes in here from the antenna, gets digitized. This is analog to digital converter. This is what brings the analog signal in from the antenna and converts it into numbers. The numbers come out of the ADC as digital numbers that the FPGA can process. Coming through here and here, get sampled in here, and they come out here. Goes into the FPGA, gets processed. Typically we just do a fast Fourier transform on the data, send it out over the Ethernet ports out the backside here, and they go into a switch. You generally want to get signals from all the antennas into one computer so that you can combine the signals in various ways. Sometimes you add them together, sometimes you multiply them, but you want to combine all the antennas together, and to do that in one computer is usually too much to do all in one computer, so we chop the data up into the signal up into subbands, as we call it, which are easier to process, and then we can send the subbands off to different places, so each computer will process just a small portion of the data. So by combining the antennas signals together, you get better sensitivity and you can get a clearer picture of what's happening. So a lot of what we do is number crunching on the computers, and to do it, we don't actually do it with the CPUs. We use these graphics processing units, which you might use for gaming. We use them just for the computational number crunching that they can do. They have a lot of processing cores on them, and they can do a lot of operations in parallel, mostly receiving packets from the network to shove onto the GPU to get the next batch of data processed. So these are some computers that just host boards like this. We use 10 gigabit Ethernet to transfer data from the FPGA to the computers or to other FPGAs sometimes. Most of what we do is called streaming processing, where the data is always coming in. Data always comes from space, signals always come from space, and so when the antenna is sending us signals, the signal is always coming, and so we have to keep up with the signal, and it just streams right through the system, and so the system has to operate basically in a real-time mode so that you can just feed the signal all the way through as if it were just some passive device, even though it's not passive, it's very active. This Radian GPU is actually related to Hera, which is a different project searching for the epoch of reionization, running in the telescope array in South Africa. Different GPUs have different capabilities. The Radian GPUs from AMD have very good integer math, and most of what we do with ADCs are all integer stuff. Some floating point stuff is being done in FPGAs these days, but we do integer on the FPGA. It's much simpler to do the math that way with the logic gates, so that's what we do. Kind of benchmarking this one as an alternative to see if it goes faster than these guys. This is Serendip 6 mostly. Serendip is the search for extraterrestrial radio emission from nearby developed intelligent populations. And this is the 6th generation of this project. It's been through quite a few generations. So it's been running at Arecibo for a long time, and now we have one running at Green Bank, which is relatively new. I think it's the first Serendip that's been at Green Bank. Arecibo's more multi-beam, covers more of the sky, and Green Bank has very narrow beam but very high sensitivity because it's a large dish. And I started working with the SETI group here through the Serendip project, Serendip program, building gateware for them and some software for them, and went to Arecibo and installed the instrument there. Just sort of morphed into working in the SETI.